Hi everyone, today we are going to explore the concept of sorting and some of its sorting algorithms. In our group, we are tasked to make a sample code implementation using selection sorting algorithm. But before that, let's have a simple introduction about sorting. Sorting is known for a systematical way of arranging or organizing data according to what data they are included. For example, we are sorting a pile of trash, which we are organizing it according to their types, which we have the biodegradable, non-biodegradable, and recyclable. Also, we can use sorting of numbers and sorting of names as an example of sorting. Having that all mentioned, let's dig into the code. Here we have a sample code implementation in selection sorting algorithm using Python. In this first snippet of codes, we are going to declare nested for loop. This is the part where the scores were organized. And here, it is a way to compare the scores according to which is the lowest and which is the highest to arrange them properly. Here, we are going to declare an empty list, which we have the list or empty list for names and scores. Here in while loop is the part where the values will be inputted if it is the name or the score. It is the part where the inputted name and scores will be added to the list. In this last snippet of codes, it is the way of displaying the sorted list, which name corresponds with the score and will be sorted according to which is the lowest and the highest. Let's now run the Python code. Upon running, similar to what is on our code, you have to enter the name. It has a condition that you can put down if you want to already sort your inputted values. For example, I am going to put my name, which is ELYSSA OLIVARES, then enter. Then I will put my score. For example, I have a score of 24. Then another name, let's put MARIZ VILLARUEL. She's my group mate. Then she has a score of 26. Then we'll have GABRIEL CONCEPCION. For example, Gab had or have a score of 20. Then Joshua SARIO. Then, for example, he has a score of 19. Then all of that are my group mates. Then, since I am done inputting our scores, I will type done so I can see the sorted list of our scores that corresponds with our names. As you can see, the output just organize the scores according to which is the lowest and the highest. And that can be essential upon organizing grades, especially when after an exam, it is easier for the professor or the teacher to identify which students have the highest and the lowest grades. Moving on, we have here another code to be compared to our chosen sorting algorithm, which is the selection sort. Here we have a sample code implementation in exchange sorting algorithm using Python to be compared to the selection sort. They have similarities on the code, but they differ in this part, which for nested for loop, which the comparison or the sorting process is different from the other, since on this part, the value of j is added by 1 to denote which is the lowest or the highest. And here in the last snippet of code, it is actually same with the other one, which corresponds the name and the score of the student. I am going to run this code, so you can see that it has a similar output with the selection sort, since it is our proposed solution. On running this code, you can see that it has a similar display to the first code, which is for selection sort. Then let's put the similar values that we input on our last sorting algo. Upon completing the list of the names together with their scores, we're going to type done. Then sorted exam scores from lowest to highest will be displayed. As you have noticed that both of the codes have a similar output, which is really the goal of our proposed solution to our specific problem or real life problem. Maybe both selection sort and exchange sort have similar output. They differ on the ways they sorted the list of the scores. The key differences between selection sort and exchange sort is that selection sort always selects the minimum element from the unsorted part of the list and places it to the correct position. While in exchange sort, it repeatedly swaps adjacent elements to the larger or smaller elements toward the correct position. Considering both selection sort and exchange sort, they actually have similar time complexity, and in conclusion, the selection sort is generally better when you want fewer swaps or comparison. And somehow, exchange sort may be slightly faster in best case scenarios due to early termination but tends to perform more swaps. That's why it consumes more time complexity. But for larger datasets, both algorithms are inefficient and you may want to use more advanced sorting algorithms.